Okay, so I should be live now. Again. Chatter doesn't want to start. Or does it? Need to get rid of this login in the background. Switch is gonna collapse again. Okay, so I should be live. Did it? Hold on. It's not what I expected. Didn't change QOTD. Ah, let's leave it as is. I need to notify, maybe. Or else no one is gonna watch me. I wonder how do I... Okay. Here's my Discord. Well, I guess just a compiler. It is the backend, the toolchain. Oh, hold on. Delete. Now this is better. Okay, we also need to automate this somehow. Why do I have a vertical scene? We are ready to actually work. I'm sure this will be another very interesting stream, and I will have exactly one viewer, which is an overlay. How surprising. Okay. Oracle. I did some work yesterday. I rewrote a parser by hand. Check out commits 19 hours ago. Those 19 hours were, wow, it's actually a lot. So give me commit history. 18 commits. That's not a lot. Just 18 commits. Okay, so April 20, we did this on stream. Then I've tried to parse expressions, to prepare for expressions, but it didn't work because LLR pop is LR1 grammar. LR1 parser generator, sorry. So I've decided enough. I'll write a parser by hand again. I've experimented with parser combinators, but decided to just use my hands, do it all manually. Because why would I use parser combinators? They are slow, they don't really accelerate much, and I'm parsing a programming language which is easy to parse without combinators, relatively easy. And then I made kind of working strings. So I made a C string literal. Oh wow, I've copied code from ripgrep, modified it a lot. So here we have string on escaper, which basically gets a string literal ABC new line. I even implemented this. No, that's not a valid Unicode character, but I guess. Um, so it turns it into whatever it actually is. So we have some stuff, string constant, which actually contains bytes, and it's not just a string constant, it's a C string constant, and how we are using it right now, we're just declaring a global object called data with hidden linkage and using it here. That's a terrible way to do it, because, I mean, it's a global object. Um, so we can only have one string at a time. Let's actually try to make more. Simple or and I was testing functions, and there is another problem with them. Let's not worry about it right now. So put string, a string, one string, and hello there, another string. Let's how do I run it here? Let's run it, compile and run it. If you're wondering who I'm talking to, I mean you. Wow. I'm talking to myself so much. This is gonna be recorded to YouTube VOD, so I'm not that mad. Someone is gonna watch the VOD and see me struggle here. Hopefully. 91 created, it's not bad. Okay, so we have this IR. Then error duplicate definition here. So I'm thinking of doing a string pool, which should fix this issue. Do this. Huh. Hold on, it should be the other way around. Yeah. So crane lift expression constant, I guess. Here. So let's imagine we have. Come on. Another Vim. I really need to make my own Vim configuration. This might be a stream on its own. But since no one is gonna watch it anyway. Right now I'm really hurting my analytics by streaming to one viewer. Could just create 3 more fake accounts and just hook them up to Twitch IRC like I did with Chattery and get affiliate, but that doesn't feel right. So I need an object. Object will contain string pool. And might actually use it not only for strings. Like maybe I actually should use it. Should say it's just a constant data. Oh, we have viewer counter. It got up to 2 so long. Okay. Let's say constant data, which is an option of a vector of 8. And they don't actually know how to get a relative address, how to offset into it. I think we can figure it out. Data none. So let's add guess I may make constant module exit add constant folder directories and move like set is here, rename it to module mod rs, and now also add pool rs. Why am I using my mouse so much? Like mod pool. So we're gonna implement create object public function constant, I guess value will be a slice of u8, and it will return a value which is a crane lift IR value. Why am I importing it? Let's say qualify 6. So how do we actually make it? If need to pass self also. Mutable self self constant data get or insert vector new. You just let it, and this should return me a mutable reference equals right now we are where is it? Constant. Right now we are declaring I mean, what is it? We are declaring a section, or is it a segment? I'm lost already. Okay, so let's say it's a section. We're declaring data section, defining it immediately, and then we import it into a function. Let's say, and then we are just symbol value. This takes a memory. What's this type? A type that can be stored in memory, global value. So local ID declare data in function returns me a global value. Oh, it's interesting. How can I offset into it? Is there a method to do so? I guess not. How can I offset into global memory? Crane lift offset into global value. Z. Earth Day 2024. How could I miss that? Actually. I mean, I have this open here. What will it show me? Global global values. A global value is an object whose value is not known at compile time. It is. I mean, I'm using constants, but I don't know actually how to make constants here. Value types, overall structure. Cliff file. I guess that's IR. SSA. Test the year right. Valid for target. Okay, I guess SIMD. We're not doing SIMD right now. I'm not doing SIMD right now. Pseudo types and classes. Yeah, I was wondering how to use those. These are not concrete types, but convenient names used to refer to real types in this reference. IADDR. I address, I guess. A pointer-sized integer representing an address. S2 64 IB. Any scalar integer types. Int. Any scalar or vector integer type. FB. Either of the floating point scalar type. Either. Just two of them. Float. Any scalar or vector floating point type. Whatever. Any SIMD vector type. Mem. Any type that can be stored in memory. Interfloat. Testable IN. What is this? Immediate operand types. I guess. Control flow. Basic blocks, and kinda don't know how to use them. I mean, I know that basic block is a block where execution is linear, kinda, something like that. So it starts with a label basically and ends with a branch, any branch or jump instruction, conditional or unconditional, which leads to a start of another basic block. So function calls, I mean, I think I already figured it out. No variadics, unfortunately. Or fortunately. Actually, we can test variadic function without variadic arguments. I'm not gonna do that right now. Fully general load and store instructions for accessing memory. Oh. If the memory at the given address is not accessible, the behavior of these instructions is undefined. If it is addressable but not accessible, they trap. What? More strict operations. Instructions are provided for handling multi-register addressing. Explicit stack slots. Wow. One set of restricted memory operations access the current function stack frame. The stack frame is divided into fixed size stack slots that are allocated in the function preamble. Stack slots are not types, they simply represent a continuous sequence of accessible bytes in the stack frame. Yeah, I guess. I mean, I need to invoke crane lift front end from my Rust code to generate this all. When crane lift code is running in a sandbox, it can also be necessary to include stack overflow checks in prolog. I guess. So global values. I need a constant, oh, constant materialization. Iconst, yeah, I know about those, but even iconst doesn't support 128 integer types. How am I supposed to fit a string into it? A few instructions have variants that take immediate appearance, but in general, an instruction is required to load a constant into an SSA value. So global values, I guess we are using them, but there should be a way to make a global constant section. A global value is an object whose value is not known at compile time. The value is computed at runtime by global value, possibly using information provided by the linker via relocations. These are multiple kinds of global values using different methods for determining their value. CraneLift does not track the type of a global variable, they are just values stored in stack memory. Non-stack memory. When CraneLift is generating code for a virtual machine environment, globals can be used to access data structures in the VM's runtime. Am I reading too bad? Probably. Chains of global value expressions are possible, but cycles are not allowed. They will be called by the IR verifier. Chains of global value expressions? What do you mean? I mean, it's verified, so I guess I shouldn't worry about it. It's gonna catch on tests. Global value. VMCTX declare a global value of the address of the VM context struct. What? I mean, it's all probably just in time. The CRDoc mostly. Maybe I can somehow. I mean, I know I can somehow use this with CraneLift frontend. A global value can also be derived by treating another global variable as a struct pointer and loading from one of its fields. What? How am I supposed to do that? Okay, I guess let's just open CraneLift docs. CraneLift, what do we need? Frontend, CodeGen, probably CodeGen. Compile timer. We need instructions. We need, what's that? Variable args. What? No, it's not supported in CraneLift. Normal VA args, C style. They are not supported. There is an issue on GitHub for that. We are using instruction inst builder. Inst builder. I think it's a trait. So message jump br table, yeah, debug trap. I don't know what this is. I guess some form of panic. I mean, terminate execution conditionally. I guess code, a reason code. What is trap code? Oh, User call. So that's how you terminate programs the right way. Trap when zero. Okay, so there are basically a lot of ways to panic. Hopefully we won't need them that much. Return calls. Get the address of a function. Splat. Vector splat. I mean, there is an well, not assembly. There is a green lift IR instruction for vector splatting. Why? Some people don't include it. x86. Special instruction for x86. Even x86 64. That's not how you write this architecture. You say x86 64 with an underscore or a dash. Lane. What's the lane? Lane index in x. An index is an immediate value, not an assay value. Get a valid index. I mean, I guess, yeah, SIMD. I guess something like array indexing. A lot of mins and maxes. Signed addition. Load here. We have a load something. Load from a memory at p plus offset. What are we using? Symbol value. Symbol value is the table address. What's that? Compute the value of global GV, which is a symbolic value. I mean, this returns. It takes a type. Any types can be stored in memory. It loads a pointer. I mean, yeah, I guess. And now we need to add to it somehow. Can I instruction? I add not like that in builder. Insert. I add. We take local symbol, which is just a pointer value. I mean, I know that because I'm passing it as a function parameter. And then we add builder ins. Of course, we can't do that because Rust checks mutability in this line very weirdly. I const. What's that? Wow. I const integer constant of a pointer type and a value will be an offset. I mean, this is weird. Global value. There should be value of global GV. Huh. Oh, which is a symbolic value. What does this mean? Does this mean it's a pointer, like TLS value? Global GV, which is a thread local. Oh, I mean thread local. I see what this is. Pinned registers. Oh wow. Frame pointer, stack pointer. I guess we can just use normal operations. Gold.org. Right? Yeah, right. Hey, viewer count jumped back to 2. So let's say we have a function that takes a char pointer string. We're coding in C. Just in case C++ does some weird stuff. Let's return a char, no, a short unsigned short int. Why am I doing this? Take strings 05 and almost wrote s. So say it's unsigned short int. Shift is left by 8 bitwise or with a string of 8, say, and GCC x8664. What do we have here? Move arrayx keyword pointer. Okay, so it takes pointer, adds 5 to it, and then does some stuff. And same thing here. So we can just do this, I guess. Let's now do actually a constant pool. Let's try first a search approach. I mean, let's extend. Let's do a simple approach first. Extend from slice value, and let's take address, or better offset. Is a pool.length, and say, oh, and actually get or insert with. So if we are haven't yet got a pool, we need to declare it so we can use it. This will be a hidden object called constant, or the constants, or sometimes, I mean, sections are called RO data, but I don't know if it's related. Expected no method declare. Oh, I need to import a trait. Okay, so module result. Of course, we're gonna unwrap this. Writable bool. So actually, we are declaring a read-only data. Oh, wow! View count got to 3. This doesn't really mean anything, but sure. So how do I actually do this? Actually, I should probably not only hold data here, but an ID as well. So ID and data. This ID is, what is it again? Data ID. Simple. Data ID. Oh wow, it's a lot. So oh wow. Generate delegate qualify. Let's just, oh, we need 3 or 2. I'm gonna do 3. Uh, wouldn't it be easier to do it manually? Come on, what? What did they implement? To qualify. To. Could just throw this and fighting with intelligence and stuff. Okay, so we have. I'm gonna take this out completely. We have declared it with a hidden linkage, not writable, not a thread local storage. Maybe we should make it a thread local storage. And so ID and a new vector. Let ID and pool. And ID will be immutable. Let's make it just Doesn't it work like that? Okay, let's actually paste this. We have declared it already. I mean, what? Expected struct data ID. ID gets mutable. Can't I pattern match it to be not a mutable reference? Huh? Okay, yes. So we are extending a pool, and then okay, we're gonna do this later. Declare data in function. Yeah, we need to declare it in function first. And I wonder if I declare it in function multiple times, will it go terribly wrong? It's local ID. Yeah, let's leave it as local ID. A pointer, let's say pointer type. Builder. Yeah, I need a builder. And let's rename this to add constant to pool. Such a long name. But I mean, since it's an global struct, it should be pretty long. It should be identifiable. Okay, so the reference here. Why it's not formatting? Unexpected token. Oh yeah, makes sense. So yeah, builder, have a function builder. We are taking a local ID. Do it like that, I think. Then we are loading it. Can't I inline it? Huh? Just me, I can inline it. Can't I? Actually, maybe I can't. Take some mutable. No, can't just inline it, unfortunately. So we are getting a symbol value, and I need to import an instruction builder trait. Now back to one viewer. I mean, who'd like to watch this kind of a stream? Maybe if I set up a Docker container and connect it to a Twitch IRC, I might do this one day. So we have a local symbol. That's basically a pointer to a value. And we are adding to it a constant offset immediate 64 from use size offset as immediate 64 integer 64-bit signed integer. So here we have in settings value found IR value. Really? I mean, this probably should be IR value or whatever value is a local symbol. It's huh? Give me, come on. This value is, what is this value? Where is it from? Where did you come from? Yeah, it's AR value. You could see on the left. Let's close this left panel so it's not scaring us away, scaring the viewers away. Type annotations needed. Yes, integer 64. And yeah, let offset. And then I add to a local symbol offset or offset. And this gives me an instruction. I mean, not an instruction, but a value. And here I can also actually self constant data, not like that. Add constant to pool. Builder function builder, and value is bytes. and wrap this in sum, because we actually return a constant, not a none or whatever unit type. Might actually turn this into a slice? I don't think so, because structs and stuff. Actually, this will be such a pain. Yeah, used. Why it's unused? So now it should work better. I hope. I'm still worried about declaring data in function twice, but it's probably the least problem we can have, which I actually don't know how to solve if it occurs. Oh wait, hold on, we didn't even declare, define it. I forgot about it. How can how can I forget about such an important thing? So we've built all items. Next we are, why am I uncommenting in such a weird way? Object. We define data if let some constant data equals object constant data. Let's define it. Define a constant data, and this constant data is a tuple. Yeah, it's an ID and data. And data will unfortunately have to data. And we unfortunately will have to do this. Function declarations and stuff. Okay, now it should. Oh, I need to also import module. Okay, now it should work. Oh, and you can't add an instruction to a block already filled. And I'm wondering if it's main or if it's double call. I think it's the problem I've tried to fix, because we need to return from a function. CraneLeaf doesn't automatically do this. We have to insert a return instruction. But if we have a return instruction last, then I mean that's a problem. We need some way of detecting if a block has been sealed or not. Or we can just always start a new one, even if it's gonna be empty. Can use to import, not that bad. Why am I importing everything from CraneLeaf frontend? When did I write this statement? Yeah, we got a panic. Entry block unknown. Oh wow. What? Remove constant PHIs. How? What? Function main, which doesn't do anything? Why? Why is it empty? Why is it empty? We have a big function main. Oh, and yeah, I fixed it. I fixed names. I mean, fixed. There are usernames and which are basically integer identifiers and test case names, and I'm switching to test case names for debug builds, so you can see it better. But I'm wondering why the function is empty. Maybe get rid of this. I really need to add comments because I really need them. Could have just commented instead of hard deleting. It's still empty. Why? Why? Oh, wait. Did you just comment out? Yeah, wait, hold on. I've commented out too much. I've commented out the whole thing. I should have only commented out this part. And we should probably get those print statements back. Hello world, hello there. I don't know why. I mean, I know. Oh, actually, I'm printing it with new lines, but put S. Oh, it's new line. We've got two strings. Hooray! I wonder if I can look somehow at an executable. Read. I have 30 sections. There is a section called constants, which is an object. I don't know how to size 30 bytes, whole 30 bytes. I don't know how to pick inside. Okay, so basic pool, constant pool done. Let's commit it just in case. I mean, just in case we just need to commit stuff more often. More often. How do you pronounce this? So constant pool, basic constant pool. And let's actually fix this problem. So the problem itself, if I add a function here, greet, for example, it won't take anything because I haven't implemented anything like for loops, string concatenation, variables. So and we're gonna put some statements here. And if you're wondering what the C means, it's just C string, because normal strings will be different. C string evaluates to a char pointer. Actual strings will evaluate to two char pointers. So we can take slices more efficiently. So this function doesn't return anything. See? And now let's call it here. And it's indented. So if we call it what is gonna happen is this. We get an error. Block does not end in a terminal in a terminator. What's wrong with me? Block does not end in a terminator in a terminator instruction. What's wrong with me? I've been streaming for only 54 minutes. I mean, I've slept only like 6 hours today. As always, every day. So it's verify error. Basically, it states that we can't have a function that does not return. We need to return from it. And that's why, I mean, we need to return from it. But we can't, if I just return from it, you'll see, as you already saw, let's just build it. And while it's building, I'm gonna be right back. I'm back so quick. What? Oh, overview looked weirdly. So here you go. We have a function, main function, which contains a return expression, and then we return again. So we can't add an instruction to a block that's already filled, because we have filled this block with a return, so nothing can come after it. But we put another return. The simplest solution for this will be something like if we have a return expression, here we do a builder and we have a create block. That block equals this builder switch to block. And I'm not sure if it's gonna work because I'm not sure if I understand basic blocks correctly, but hopefully I do. So switch to block should make a route to this return. Why couldn't we just optimize with 3 address code or however it's called? Why do we need to make some basic blocks? Who needs this weird thing? Who needs compiler optimizations? Are we still streaming? Let me open YouTube. Hopefully we're still live. Chatry. Oh, that's slow. Okay, so arguments of return does match return must match function signature. Yes, this is a problem. We can't just return. We can't just put return into a main function because it returns a value, and they have to return a value that it requires. So I don't know. I mean, this should be called by a type checker, but return is actually a never type, so it should cast, etc. And I don't know how to fix this. Actually don't know. And so we have this block which evaluates to a unit expression, so nothing. Even though it ends with a return null, so return 0, so it should evaluate to a never type, which should be anything. We shouldn't just insert a thing here. And I don't know how to fix it. I mean, we shouldn't insert instructions right after return. That's the thing. But how do we detect? We can't check if a block is sealed or not. Function builder, is it in, I think it's in module or in front, it's front end. Lift front end. Function builder. Here we have a function builder. Set source location, create block, set cold block. Insert block after, switch to block seal block. Function to call with the block as soon as the last branch. Function to call with block as soon as the last branch instruction to block has been created. Block will cause inconsistencies in prediction functions. Send block on all unsealed from the function as soon as possible during translation, but for frontend do this function can be used at the end of translating all blocks to ensure that everything is sealed. Yes, let's try it. So we need to seal a block after return, after a return expression, and that means here. It doesn't really help here. No. I still need to return, but I can detect if a block is sealed. Declare variable, try use it, try define it. Set label, create jump table, stack slots. What is that? I mean, it's basically function importing. By the way, is it wrong that I'm doing everything twice here? So greet function, where is it? Wait, take a look at it. No. Okay, we'll see later. Ensure inserted block. Cursor. Function cursor pointer. Position ready for inserting instructions. So C code doesn't need access locals and doesn't need to know about function builder at all. Append paralog params for function params. What is this? To the given block and block parameters for entry block. What? Finalize. Am I finalizing it? I don't think I am. No, I don't. Builder finalize. So the block should evaluate to a never type. What do we do with that? I mean, I should just add type checking, right? Shouldn't I? I also need to add type casting. This would be useful, right? Because right now it's a typed language, but types aren't checked at compile time except for crane lift doing some heavy lifting for me. Function builder finalized, but block is not sealed. Yeah, right, sealed. I need to seal it. So I should call builder.seal all blocks. I am gonna seal every block manually, but just in case I don't, and for the final block after the return expression, if I do so, I'll call this function. So after a return expression in here, I think I should seal. Come on, I should seal builder seal a block builder current block. Is this right? Oh, it turns an option. I think I'm good with unwrapping it here. Here we have, let's just quickly add a return 0, for example, and it's gonna return a byte. Because why not? So just so we can see if it compiles and doesn't break. And I'll need to do some type checking, actual types on the IR structures. So let's just quickly go to. Oh, I don't even know where to start. Probably expression. I mean, probably I need to add types to expressions. So right. Let's close everything else except for expressions. Is a block expression? Yeah, we kinda need this. It's kind of not a place where I should put it because it doesn't. It's not related to an intermediate representation, only to the way it's printed and parsed. I mean, let's leave it here for now. So we have a type inference. Well, I say type inference. I mean making integer constants are the right type. So let's do get type. I mean, let's first write the function. Maybe I'll write it for me. R hash type. A good function name, right? Type, yeah. Why am I borrowing this type? I mean, I kinda should borrow it. Maybe actually should make it a cow. I don't know. Let's borrow now. Get the type of the expression value. Expression. So basically type error, yeah, right. This should actually be I think ignored, to be honest, because this is already handled elsewhere. I mean, on lexing or parsing process. After that, this error should be handled already. So yeah, this is turn scope. So you're suggesting me. Oh, it's type ID. Okay. There are no actually types. Return. No, that's not right. Return of any expression evaluates to type, which is a type never. And it's probably won't compile because I can't just reference. Actually, I can. It's a static. It's a content. It's a constant. So I can reference it actually. I mean, the type is probably stored somewhere. So maybe it's fine. So a constant type binary operation common type. I need to means this they should be equal. So should I call this type checking or just get a type? I mean, I have to type check in this function, but I kinda don't want to type check more than once. So I'm just gonna return a left hand side type here. I'm gonna do a type checking, actual type checking separately, I guess. Or pass a bool here, pass a boolean value here. So check my types, please. So yeah, type actually report bool. That's not really a great thing to do, but I guess it's fine. Come on. So left hand side. Let's let LHS left hand side equals and side right hand side type. Okay, so if a report, I also check types of those expressions. This feels wrong, completely wrong to me. What should I say? Check. Okay, so for constant, for block, and for a signature, I'll need. I think this. Oh, this requires type inference struct. Oh, wow. This will be hard. This is painful. kind of. I mean, when I run type inference, uh, I should run type inference first fully. I should run type inference, complete it, and only after that I will be able to check types. So I can't really use type inference information here. What does it stores a root module or just a module? This is hard. I mean, I need type checking. I need a scope. I think I should do this off stream. No one is watching me anyway. Yeah, my Twitch stats just terrible right now. So I guess we're ending here.